In this video, we're going to learn about how to read solubility curves. So first off, some definition stuff. A solution is considered saturated whenever its concentration is on the solubility curve. It is considered unsaturated whenever its concentration is below the solubility curve. And it's considered supersaturated whenever its concentration is above the solubility curve. So if we're looking at a solution of, say, potassium chlorate, KClO3, at 100 degrees Celsius, the solubility is approximately 60 grams of KClO3 per 100 grams of water. If you're at that exact point, that exact concentration, you have a saturated solution. Anything below 40 grams, 50 grams, 57 grams, 59 grams of KClO3 per 100 grams of water, that would still be unsaturated. Anything above that 60, 61, 62, 65 grams, well, that would be supersaturated. All right, so now to answer some questions, solve some problems. How many grams of NH3 can dissolve in 200 grams of water at 10 degrees Celsius? So that's our question. And this is going to be a dimensional analysis problem where we start with the 200 grams of water. And we need to figure out how many grams of NH3 are going to dissolve in however many grams of H2O. And as it happens, on this solubility curves chart, we have the vertical axis as grams of solute per 100 grams of water. So I'm actually going to put in 100 grams here. And again, how many grams of NH3? Okay, we have to find our NH3 curve, which is right here. So at 10 degrees Celsius, we will find that the solubility is approximately, I'm going to call this 70 grams of water, NH3 per 100 grams of water. And what this comes out to is 140 grams of NH3 that can dissolve in 200 grams of water at 10 degrees Celsius. Next question is 57 grams of KClO3, potassium chlorate, are dissolved in 100 grams of water at 100 degrees Celsius. So that would be right here. Our solubility curve would be right here. Is this solution saturated? Well, looking at it, I see that I'm going to call this 60 grams of KClO3 can dissolve in 100 grams of water at 100 degrees Celsius. So since we only have a solution with 57 grams of KClO3, there's still room for 3 more grams. So this is unsaturated. Next question. The solution is cooled to 90 degrees Celsius. What mass of KClO3 will precipitate in order to reestablish equilibrium? Well, if I know that there are 57 grams of KClO3 that are dissolved in the solution, and I know that, well, let's see. We go down to 90 degrees Celsius, and this is, I'm going to call this 50 grams of KClO3 that could dissolve, that constitutes a saturation point. So I'm going to say it's 50 grams of KClO3. KClO3. And so what this gives us is 7 grams of KClO3 that would precipitate out. If we were dealing with more KClO3, let's say we had, it were twice as much, and you had 114 grams of KClO3 dissolved in 200 grams of water, we would have to take this 50 grams and double it, because then in 200 grams of water, there would be 100 grams of KClO3 that could dissolve in it, and we'd end up with 14 as our grams of KClO3 that would crash out of solution as a precipitate. Anyway, I hope this video has been helpful. Feel free to leave any questions or comments in the comments section below.